Hello, class. We're going to continue working on reviewing for the final exam. Question number 21. Find an equation of the line that has the given slope and passing through the given point. And this is a very classical problem, and you must know how to solve it. Since the problem requires us to type your answer in slope-intercept form, you're going to write a formula for the slope-intercept form of a straight line. Y equals mx plus b. All right. Since the slope is given, m equals -7, and then we also are given a pair of numbers. Yeah, we are given a point, 1/2, 4. That means x equals half, y equals 4. We can plug them in. Okay, plug in m equals -7, x equals half, y equals 4 into this equation. Let's see what do we have after that. Y is 4. M is -7. X is half plus b. And 4 equals 97 times half. Half of 97, 93.5, right? Yeah, I do not recommend a decimal, but sometimes decimal make it a little bit easier, especially decimal is a very simple decimal, 93.5. And if we add 3.5 to each side, we would have the value of b. 4 plus 3.5 is 7.5, that is b. And b is 7.5, is 7.5, right? That is 15/2. You can double check, half of 15 is 7.5, right? Yeah, $7.50 is half of $15. So b as a fraction is 15/2. Once we have the value of b, we are done. We have our answer is y equals m is 97, x plus b is 15/2. This is the answer, okay? It says you're going to type the whole equation. The equation of the line is y equals -7x plus 15/2. Y equals -7x plus 15/2. Okay, next. Question number 22. Write an equation of the line in the figure. I have to make this smaller, then I can see the whole picture. The equation of the line is, I'm going to type the equation in a slope-intercept form. So I need to know the slope. I notice there are 2 points in red, right? I'm going to go from this point to this point. I know the slope is going to be positive because the line goes up. The line rises. And from this point to that point, rise is 3. Okay, 1, 2, 3. Run is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the slope rise over run is 3/5. Okay, y equals 3/5 times x plus b. B is the y value of the y-intercept, and the y-intercept is given. Okay, the intersection of the straight line with the y-axis is this point is the y-intercept. The line cut the y-axis at -2, 4. Okay, hold on. I need to make it bigger. Sorry about that. This is the biggest I can go. -7. Yeah, -7. Yeah, -7. So we're gonna -7 here. Okay, plus -7 is -7. -7. There we go. Question number 23. graph the region described by the inequality. X is bigger than or equal to 6. Okay. So we're going to follow the steps of the process. The inequality is X bigger than or equal to 6. Firstly, we're going to change the inequality symbol as equal sign. And this is the boundary line. Okay. The boundary line is a vertical straight line, turns out it's a vertical straight line. And it's going to be a vertical line 6 units to the right of the origin. And we also want to know which side of the straight line is the solution set of the inequality, right? So we're going to use 0, 0. And if we plug in x equals 0, we got a false statement. So that means 0, 0 is not in the solution set. Okay, 0, 0 is not a solution. I want to make it bigger here. This is how do we do it. We're going to draw the boundary line. When we draw the boundary line, we need to decide a solid or dashed line, right? It's going to be solid line. This is the origin. 1, 2, 3, 4, 5, 6. Yeah, x equals 6 is the vertical straight line. Remember, 0, 0, the origin is not a solution. So we're going to shade the region to the right of the boundary line, okay? And knowing the boundary line is going to be a solid line because the original inequality symbol is bigger than or equal to. There's a bar underneath. The bar represents the equality. That means all the points on the boundary, they are solutions as well, okay? Next, question number 24. This is from chapter 5, right? Very straightforward. Those two kangaroos standing next to each other, right? We're multiplying two exponential expressions with the same base. We keep the base 5 and raise the exponent. Yeah, raise the base to the exponent. 12. Is that 12? Yeah, 12 plus 16, which is 28. That's it. You do not need to evaluate. It says use the positive exponents only. Yeah. So leave it as an exponential expression. Question number 25. This is the quotient rule. Since the two exponential expressions have the same base, the base is going to be 11, right? 11. Oh, hold on. But the denominator has a bigger exponent compared with the numerator. So we're going to have 1 in the numerator, and we're going to have 11 to the power of 4 in the denominator. Okay, 19 minus 15 is 4. So the 4 is going to be the exponent in the denominator. Yeah, let's read the question. We're supposed to read all the details. Simplify your answer. Use integers or fractions for any numbers in the expression. Type exponential notation with positive exponents. Yeah, that's correct. We don't have to evaluate. This one is a bit more complicated. You might use multiple formulas. Let me copy it. I have 3x over 5y cubed squared. I see a power of quotient. Power of quotient equals quotient of powers. So numerator to the power 2. Denominator to the power 2. Okay? And the numerator, yeah, only look at numerator right now, is the power of a product. So we're going to have first factor to the power 2, second factor to the power 2. Same with the denominator, 5 to the power 2, y cubed to the power 2. All right, this step, we use the power of quotient. This step, we use the power of a product for both numerator and the denominator. And next step, we're going to use, I copy those things, power rule to simplify this detail, this part. Y cubed and then to the power 2 is the power rule, y to the power 6. All right. 3 to the power 2 is 9. 5 to the power 2 is 25. And this is the final answer. We're going to have a quotient. Numerator 9, x squared. 9x squared. Denominator 25, y to the power 6. 9x squared, 25, y to the power 6. Okay. Next. This is a power of product. Firstly, I see a power of product. I do not worry about the negative exponent because I know if I apply the power rule, later I will not have a negative on the shoulder of y. So this is the power of a product. The base is a product. First factor 2, second factor y to the power negative 3. We have 2 to the power negative 3 times y negative 3 to the power negative 3. Okay. This part we need to use the negative exponent formula. 2 to the power negative 3 is 1 over 2 to the power 3 times power rule. Keep the base y, multiply the two exponents, negative 3 times negative 3 plus 9. 2 to the power 3 is 8, 1 over 8. Yeah, I encourage you to use calculator. Do not write 2 to the power 3 equals 9. 2 to the power 3 is 8. 2 times 2 times 2, right? And then we would have y to the power 9 all over 8. And that's the final answer. Y to the power of 9 all over 8. Next. 28. Scientific notation. We're going to write the number in the decimal notation. The exponent is negative. That means we are going to move the decimal point to the left 5 times. We're going to have 1, 2, 3, 4. 4 zeros in front of 5. And double check. In total, we have 5 zeros. 1, 2, 3, 4, 5. Okay. 29 is a trinomial. They ask the degree of the trinomial. Degree is a 7, okay? The biggest number on the shoulder of variable x. Is this a monomial, binomial, trinomial? Of course, trinomial. 3 terms. That one is very simple, so please do not mess up that problem. And then use the formula for a binomial squared to multiply. This is a special multiplication, special product. 7x minus 4 to the power 2. 7x minus 4 to the power 2. It is 7x minus 4 times 7x minus 4. Build a box 2 by 2. 7x minus 4. 7x minus 4. Row 1, column 1. 7 times 7, 49. X times x, x squared. 7x times negative 4, negative 28x. Negative 4 times 7x, negative 28x. Negative 4 times negative 4, positive 16. And those two terms are like terms. And add them together, we have negative 56x. And with the 49x squared and a 16 here, the final answer is a trinomial degree 2. 49x squared minus 56x minus 56x plus 16, right? All right, next, 31. Okay, divide a trinomial by a monomial. 15, that is the first power, minus 20, y cubed, minus 10, y squared. Divide that by a monomial, 5y squared. Split it up. Split this one quotient into 3 quotients, okay? We're going to use term 1 on the top, over the term 2, over the bottom, plus term 2 on the top, over the bottom, plus term 3 on the top, over the bottom. Simplify. 15 divided by 5 is 3, square on the top, 4 minus 2. Negative 20 divided by 5, negative 4, y cubed over y squared is y. 3 minus 2 is 1. 10 divided by 5, 92. Yeah, this is the answer. Okay. 3y squared, 3y squared minus 4y minus 2. 3y squared minus 4y minus 2. Okay. Question number 32. GCF and then okay, and then factor. Okay, so this one, today we just actually seen a similar problem in the review of test 3. We just need a factor of the GCF. The remaining polynomial is not factorable. Yeah, because of this a, as you can see, the a here only appears in the second term. The GCF is going to be y. Yeah, I don't see any other. 2 is a prime, 5 is prime, 7 is prime. Yeah. So after we take out y, first term become 2xy, 2xy, and then minus 7a plus 5x minus 7. Okay, let me double check. 2xy squared minus 7ay plus 5xy minus 7y. The polynomial has 4 terms inside the parentheses, however, it's not factorable. Why? How do you know that? Because this a, letter A. There's no way we can group them and then we end up with a common binomial factor. All right, so that's the answer. Question number 33. This is a polynomial with 4 terms, and this one can be factored by using grouping method. Let me write it down. 3x plus bx minus 12a minus 4b. Minus 4b. There are signals or signs tell you if a polynomial factorable or not, right? And we can do the first 2, the last 2. The first 2 can factor out x inside the parentheses, 3a plus b. The last 2, we need a factor of a negative 4, okay? Yeah, both of the 2 terms are negative, so we should know we need a factor of the negative GCF, which is negative 4. And then we have 3a plus b. 3a plus b is in common, factor that out. We have x minus 4 inside the second parentheses. So the final answer is parentheses times parentheses. First parentheses, 3a plus b second parentheses, x minus 4. 3a plus b times x minus 4. Okay, next. 34. Factor by grouping, ignore that, okay? We are not doing that. Trinomial, we only use grouping method for polynomials with 4 terms. And this one, yeah, we're gonna take care of the GCF first. Okay, actually, there's no GCF. There's no GCF. 58 is 2 times 29. 29 is a prime number. Okay, so slide divide slide method. Looks a little bit intimidating because the number is so big. I'll show you actually it's not that bad. Slide. What is 21 times 21? 441. Okay, and you're gonna do your ABC. A is 1, B is negative 58, C is 441. And then we are looking for 2 numbers. They multiply to 441 and add up to negative 58, right? They must be both negative. Yeah, which 2 numbers? Yeah, I like to play with this. It's very interesting. 441. 4 plus 4 plus 1, 9. That means this number is divided by 3, also divided by 9. is not even, so it's not divided by 2. We're going to start with 3. Yeah, we can start with 1, but we know it's not an option, right? 3 times 1, 4, 7. Yeah. And you know the two numbers need to add up to add up nearly 58. So those are actually, we know it's not gonna work. 5 doesn't work, 6 doesn't work, 7 times 63. Yeah. And 9 times 49. Here we go. Found it. Yeah, 49 times 9 is 4 for 1, right? Yeah, 49 times 9 times 49. 81, 36 plus 8. Yeah. So the two numbers are -9, -49, because they multiply to positive 4 for 1, they add up to -58. So we are able to factor this as x minus 9 times x minus 49. And then divide the two numbers by 21, which is the leading coefficient we slid away earlier. Simplify the fraction, 3 over 7. And this one is 7 over 3. 49 divided by 7, 7, 21 divided by 7 is 3. Okay, and then we are going to slide it back. So 7x minus 3, 3x minus 7. Okay, yeah. So the answer is going to be parentheses times parentheses. Hold on. Pay attention to all the details. You mess up a little bit, it's not gonna work. 7x minus 3, 3x minus 7. All right, you can double check by factoring, by multiplying, use the box method or for you. You should always do that when you practice, you know. And this one, okay, perfect square trinomial. First base 6x, second base 5. In the middle is the positive, so we're going to have a parentheses to the power 2. In the parentheses, we're going to have a base 1 plus base 2, 6x plus 5. 6x plus 5. Question number 36. Excuse me. Yes, we could factor out the GCF, and we should. Yeah, we should. We should always do GCF first. When I see this trinomial, I see GCF. I see GCF. It's 4. Okay. Let's factor 4 out. This is 9x squared plus 24 x plus 16. And inside the parentheses, we have a perfect square triangle. Yeah, because 9x squared is 3x power 2. So base 1 is 3x. 16 is 4 squared, so base 2 is 4. Okay, the two bases. And so the trinomial can be factored as base 1 plus base 2 to the power 2. We have 4 times parentheses to the power of 2. In the parentheses, the base is 3x plus 4. 3x plus 4. Okay, that's it. Yeah, we should factor out the GCF. I don't know if you notice, this can be written as 6x plus 8 to the power 2, right? But 6x plus 8 is not factored. Yeah, it means it is factorable. And 6x plus 8, you factor out 2, you have 3x plus 4. And then you have 2 to the power 2 is 4. And this one works, but you know, you have to apply a power of the product. Just in case you make any mistake, we should always factor out the GCF first. Next, question number 37. Okay, factoring by grouping. This one is factorable, yeah. Because those signals, you see, there's a C here, C here, A here, A here. It's not just the one letter only appear in one term. It appears in two different terms. AX minus 3CX plus 2AY minus 6CY. Okay. Group factor of X, A minus 3C. Factor of 2Y, A minus 3C. So they have a common binomial factor, A minus 3C, and then left over X plus 2Y. That. The result, choose A. Parentheses times parentheses. Inside the first parentheses, we have A minus 3C. Inside the second parentheses, X plus 2Y. X plus 2Y. A minus 3C. Okay. Next. 38. I notice GCF X. Yeah, let's factor out GCF first. 42 X squared X cubed. But also notice GCF of 3. 9x squared Y minus 6xy squared. GCF is 3. 42 is divided by 3. It's 14 times 3, right? So 3x and a factor of 3x. Yeah, I remember this question very similar. Earlier today, we do the review for exam 3. So factor out 3x, we have 14x squared plus 3xy minus 2y squared. Okay. For this trinomial, notice it is the three terms, x times x, x times y, y times y. So we are going to remove y first. We have 14x squared plus 3x minus 2. Yeah, get rid of y first. And then later we are going to bring it back. Okay, and then slide method. Yeah, this is a very challenging problem. Slide x squared plus 3x minus 28. Find the two integers. Yeah, we should do ABC. Sorry. When you are get very familiar with the process, it's okay to skip steps. But we should always follow the process when we are not very familiar with that. So A is 1, B is 3, C is negative 28. We're looking for two numbers. Multiply to negative 28, add up to 3. So we're going to have a positive, a negative, right? Which two numbers? 28 is 1 times 28, 2 times 14. 3 doesn't work. 4 times 7, yeah, 4 times 7. So it's going to be positive 7, negative 4. Okay, so this can be factored as x minus 4, x plus 7. And then divide by 14. Simplify x minus 2/7, 2 divided by 7, 2 over 7, and this is x plus 1/2. Slide it back, and we have 7x minus 2, 2x plus 1. Do not forget that you have a GCF, which is a 3x here, okay? Yeah, we just did the factorization of the polynomial inside the parentheses after we factor out the GCF. Do not forget we have a GCF 3x, and you are going to enter this in the sum. Every detail matters. We have 7x minus 2. And now y is 2x plus 1. 7x minus 2, 2x plus 1. Okay. Number 39, solving equation. We covered two methods, right? Quadratic formula and solving by factoring. Both methods requires the right side be 0. And this equation, the right side is already 0. I think we can easily to factor the left side. We can get it done here. X squared minus 5x minus 24, ABC. A is 1, B is -5, C is -24. We are looking for two numbers. Add up to -5, multiply to -24. So one negative, one positive. Yeah, I see it already, but if you don't see it, just factor 24. I think it's a very interesting thing to do. Yeah, you notice 3 and 8, right? -3, -8, +3. So we can factor this as x plus 3 times x minus 8. And put it back. X plus 3, x minus 8. And their opposites, -3 and +8, are going to be the solutions. Okay, -3, +8. -3, comma, +8. Okay, one more. This is a handshake. Okay, we went through this. We went over this problem earlier today. Basically, H is the number of handshakes. N squared minus N. N is the number of people who shake hands with others, right? Once. Shake hands once with everybody else. So how many people are invited? 18, including Barry. So 18 plus 1, 19. And I would factor N out, and N minus 1, we talked about this earlier, right? Yeah. This way, I don't have to handle, I can, reduce the calculation load just a little bit, and it's fun. N is 19, then minus 1 is 18. Half of 18 is 9. And now we only need to do one time calculation, 19 times 9. By the way, if you just plugging in, totally fine. 19 times 9, 171. All right. We made a mistake. Let's see. Question number 38. Uh, 3x 7. Oh, my bad. I forgot to bring the y back. It's a long process. We remove the y, but we need to remember to bring the y back, right? Yeah. So we need to bring y back. Yeah, let me stress. You do not make the mistake like I did. So we are going to have 7x minus 2y, 2x plus y. Yeah, everything else is good. I made one mistake. I forgot to bring y back. Yeah, we removed the y earlier. Okay, so double check is always good. Yeah, the original function, the trinomial has a y, but my factorization has y disappear. So yeah, I should have be more careful. Apologize on that. Yeah, so those are the 40 questions for review of the final. I hope you redo those questions, get familiar with the topics. And I hope you choose, since it's optional, right? You choose to take it and then you can boost your score. All right. Good luck. Bye-bye.